Right. Earlier we saw some introduction to OSI. We are going to go deep into it today. OSI stands for Open System Interconnect. You see, as you said in the previous class, this is a reference model, correct? Why do we need this model? So that all the systems can be openly interconnected without any issues. All the systems in the internet can be interconnected openly, meaning, what does openly mean? Without any problem, without any struggle, without any constraints. That's why you need the standard, so that whether it is designed, whether the device is designed in India or in Africa, doesn't matter. They can talk each other. They can interact each other. Both the systems can communicate. They are open to talk. Open system interconnect. It's a common standard. When two devices built using this system, those two devices can talk. And now we also learned that OSI is a 7-layer preparation done to our data. The PC is trying to send a data to another PC here. A is sending data to B. Let us assume the IP address of this PC is 10.0.0.1. This is IP address. What is the size of IP address? That's the MAC address, 48-bit MAC address of B, and 32-bit IP address of B is 10.0.0.2. You see, one is already in use. I cannot use the same one. So I put 2 as this host identification. What is a host? Any system in a network is a host. So I have 2 hosts, A and B. A is identified with the number 1, 10.0.0.1. 1 is the host ID, 10 is the network. In B, host ID is 2. Network is 10. Okay. Now, this computer wants to talk to, A wants to talk to B. So who is the sender of the traffic? Who generates the traffic? A. Yes. Let's say A is telnetting to the PCB. It is trying to telnet to PCB. A is telnetting to B. A is telnetting to B. And this is the telnet. But you know what is telnet? If I want to see your computer, if you want to see your computer, and if I want to open your documents from my place, I remotely log in into your computer so that I can open your files. And if you don't know how to do something, I can show you how to do it remotely. By remotely logging into your computer, I can see your screen here in my laptop. I can see your correct. I can see your computer in my laptop. Whatever I do here will be done there. That is what called as telnet session. That is what telnet. Telnet is nothing but remote login. Okay. Now, let's say A want to telnet to B. A would like to telnet to B. And the telnet packet is this. This is your actual data you're trying to telnet. If you want to telnet, you need an application, right? And this is that application. Let me show you. PUTTY. Putty. This application is what we will use to tell you. See, telnet. It is written here. Do you see that? Telnet. Telnet port number is 23. And I'll just put the IP address of your computer here. For example, if I am in computer A and you are in computer B, I'll say 10. That is the port number of telnet. That's the number to identify telnet. Okay. 23 is a number to identify telnet. There is do you like chemistry? Do you like chemistry? What is the number for hydrogen in the what is the table called as? Is it atomic table? Periodic table, where we see a lot of protocols. Sorry, uh, like what is the number? Okay, number one, nitrogen. Okay, so let's take 14. If I say 14, then everyone will know it is hydrogen. Sorry, it is nitrogen. So when we say 7, everyone knows that it is nitrogen. He's talking about nitrogen. Likewise, in networking world, if port number is 23, B will understand that A requests telnet. See, B need to know that I'm telnetting. So port number is 23. If I send a packet with port number 23, when B read the port number 23, it knows that I'm requesting telnet. Did you understand the use of port number? If someone writes in the chemistry paper 7, now I will understand he's talking about nitrogen. Likewise, when A send a packet, correct. B, when it receives this packet, B will check that port number and B understands that A is requesting telnet. B understands that A want to see the screen down there. So that now B will start supporting that. B will start sharing the screen to the A. See, A and B can have different conversation. Telnet is one side of conversation. How B knows what A is looking for? By seeing the port number, it knows. Have you used that vending machine to take Coca-Cola or Pepsi or Thumbs Up from the vending machine? What do? You put the money and you type the number that is there in the vending machine. Yeah. So when you put the right number, that bottle comes into the bay where you can pick it up, isn't it? We don't type Coca-Cola, we just type the number and the Coca-Cola comes and falls down. We grab it. Yeah. So the number tells the machine product, tells the machine what product you're looking for, identifies the product. Very well said. Likewise, this number identifies the service what the requester is expecting. When B receives 23, it understands that A is expecting telnet. All right. Okay. So now going back, this is the application from where I telnet. So let's say I'm in this computer 10001. I want to telnet 10002. So I put the IP address 10002 and I put the port number 23. And when I say open, it will ask the password, username and password of your computer. And when I give the password correctly, I will be able to see your computer. But see, there is also another option, remote logging. Many options, telnet. A lot of options are there. Now, we use an application to do this, right? Those applications which is used for interacting with the network is what called as application layer. Application layer meaning what? It is the set of applications through which we interact with the network devices. We interact with other network devices. So we call here as application layer, which is layer 7. Application layer is in the top, but we don't call it as layer 1. You know why? OSI is a standard. Standard, you cannot change it according to your convenience. See, even though flow is starting from the application layer cannot be called as L1. We cannot call it as layer 1. The reason is application layer is already written in the standard books as layer 7. அது அப்பப்போ மாத்திட்டு இருக்கிறதுக்கு வாய்ப்பு கிடையாது. ஆரம்பத்தில் அப்ளிகேஷன் லேயர்னா லேயர் 7, பிசிக்கல் லேயர்னா லேயர் 1ன்னு வச்சுட்டாங்க. நம்ம இப்போ இல்லை பேக்கெட் இப்படி தானே பிறந்த போகுது, அதனால இதை தான் நம்ம லேயர் 1ன்னு சொல்லணும்லாம் சொல்ல முடியாது. சரியா? So it's a standard. Do you know who proposed this standard? Who designed this OSI? Any idea? Who designed OSI? Okay, I want to ask you a question. Who designs anything you say? There's a standard. Have you seen something like this? In a lot of products, you will have something like this, and it is said as certified, something like this. Have you seen? If you take a soap, you will see the symbol certified. What certified? ISO certified. Correct? Yeah. It is the same ISO who also proposed this standard. ISO. OSI is proposed by ISO. ISO க்கு அதான் வேலையே. என்ன வேலை? ஸ்டாண்டர்டைஸ் பண்றது தான். சோப்புனா இவ்வளவு பெருசா இருக்கணும், கை கடக்கமா இருக்கணும். சோப்பு ஒரு பெரிய பீரோ சைஸ்க்கு செய்யக்கூடாது. சோப்புனா இந்த சைஸ்ல தான் இருக்கணும், பென்னுனா இந்த சைஸ்ல தான் இருக்கணும். ஏன்னா ஒரு எந்த ஒரு ப்ராடக்ட் எடுத்தாலும் இது இப்படிதான் இருக்கணும்னு ஸ்டாண்டர்டை ஃபிக்ஸ் பண்றது தான் ஐஎஸ்ஓ உடைய வேலை. அதே ஐஎஸ்ஓ தான் இதையும் இந்த ஸ்டாண்டர்டையும் ப்ரொபோஸ் பண்ணிருக்கு, ஃபிக்ஸ் பண்ணிருக்கு. சரி, now from the application layer our data is generated. I told you we are trying to telnet, right, from A to B. The telnet traffic is generated using application in the application layer, but you see only we know it is telnet. PUTTY. Only we know that it is a telnet because I told you, you know it. I told you port number 23 and the destination computer is 10002. So you also know that I am trying to telnet. But how do network knows? Can network see my laptop? No. Network is just bunch of devices and cables. Who is going to carry this information? Network. How network knows that this is a telnet? How network knows that this is a telnet traffic? It is through this layer called presentation. You see how nicely they have named it. You use applications to interact, that is why it is application layer. There is someone to present the meaning of this data to the network so that network will handle the traffic accordingly. Have you gone in an aeroplane? Okay. When you carry some breakable items, in the check-in baggage, when you carry a breakable item like a TV or a breakable glass, when you carry it in a check-in baggage, what is check-in baggage? The baggage which we drop in the check-in counter. We don't carry it in our hand to the main luggage. We call it as check-in baggage. Now we have hand baggage, we have check-in baggage. Hand baggage can also be called as cabin baggage. We take it to the cabin. We take it along with us to the cabin. But this check-in baggage, we cannot take it. It's too heavy, as you said, it's a main luggage. Inside the luggage, you have a lot of breakable item. So you have to inform the check-in counter people that I have breakables, so that when they present it to the back office, they are the one who is going to take the baggage from the check-in counter and put it in the correct aeroplane. There are many aeroplanes, sometimes hundreds of aeroplanes in the airport. How exactly your box goes to your aeroplane? So there is a big group of people behind the screen working, whom you and I cannot see. Now there are hundreds of people or thousands of people handling your baggage. They need to know that there is a glass item inside. So what this check-in baggage people will do, to your main luggage, they will put one sticker. Handle with care, breakable item, something like that. So the check-in person, they put that fragile sticker so that everyone in the ground who is loading and unloading to and from the aeroplane will know that I have to handle this with care. No one informed them other than the sticker. Who put that sticker? Check-in counter. The check-in counter member, the person, is presenting, saying, this is to be handled carefully. Likewise, in the network should know what sort of data it is. So the presentation layer is the presenter who is telling the network what type of data. It presents it in a network language. Telnet is a human language, right? Telnet is a human word. But how network will understand Telnet? Presentation layer will make network to understand that this is a Telnet traffic. That is why we call it as what? Presentation layer. It presents the data and its meaning to the network. Now, after the presentation layer, our data got added with one layer called presentation layer. Now, after the presentation layer, our data goes to session layer. Session layer is the place where our data with the presentation layer, first the application. This box is application. Okay, this is application layer, our data inside, and then the presentation layer, and then the session layer adds the time frame when this packet should leave the computer A, and within what time the response from B is expected. All those informations are attached to the data by the session layer. Now, have you gone to a doctor for some reason? Anytime? What do? You take an appointment, right? Do you take appointment to meet doctors? Why do you do that? Why do you take an appointment? So that when you go, doctor will be available, will not be too busy in attending 20 customers, 20 patients. When you have an appointment, there won't be much crowd when you go to doctor in your time, in your given time, in the time that is given to you. Doctor should be waiting for you only, not treating others, because the time is given for you, so that there won't be wait time, so that the service will be done as soon as you go. Likewise, on this computer A, there may be many services running. So there should be a session to say at what time the processor should process this, and at what time this traffic to be kept in the network for reaching B, and within what time B should respond to A. All these informations are added by the session layer to the data. When you download, have you noticed 2 minutes to finish download or 5 minutes to finish download? Have you noticed that? How is that possible for a PC, your computer, to tell that in another 5 minutes the download will get over? It knows because of the session layer. because it maintains the session. It maintains session saying these many packets have come in this many seconds. So a remaining packet will take this long because for a 5 packet, if it takes 5 minutes, for another 50 packet, it will take 50 minutes. Yeah, 5 packet, 5 minutes. For another 50 packet, it's going to take another 50 minutes. So it's a calculation. It calculates and tells because of the session layer, it can do it. So session layer is important. After session layer, our data with the application layer, presentation layer, session layer, it gets another layer of information called transport layer. Transport layer. Transport layer. This transport layer is layer 4. See, as the word says, transport layer, this layer is responsible for transportation of data. You see, according to the capacity of your cable, the medium through which you send the data, according to the capacity, the data will be segmented here. Let's say you can carry 5 kilogram of weight, but we want to transport 50 kilogram. But how much you can carry? 5 kilogram. So what I should do is I have to break it into 10 pieces, isn't it? So that you can easily carry. Likewise, the physical layer, no, the physical media, it has got capacity. Some media will have more capacity, some will have small capacity. According to the capacity, in the transport layer, the data will be segmented. If you have a very large data, it will be segmented into small pieces. Not only that, it will also be sequenced. So what does transport layer do? It segments and sequence. Why sequencing? What is sequencing? Numbering. Let's say this is our data, but this big data cannot be carried. So what do? We segment it. We have cut it into small pieces so that it can be carried easily. Now this segment will be numbered. This is the first piece. This is the second piece. This is the third piece. Fourth, fifth, sixth. So this is what called a sequencing. Why it is sequenced? So that on the receiving side, it can be rearranged as one big data. See, when it is sent in the internet we have multiple paths to reach the destination. So sometime this fourth piece will go first, and then seventh piece may go second. It won't go in the same order, okay? On the receiving side, when the receiver receives, not all the time first packet will come first and second packet will come second. Sometime fifth packet will come first, and then seventh packet will come next, and then third packet will come next, and then first packet will come next. So there is a need for the sequence so that you can rearrange it in an order after collecting the whole number of packets. If that sequence number is not there, the receiving device will not know which segment comes first and which comes next. It is not possible to rearrange it if sequencing is not done. You see, all these are taken care by this transport layer. Why is this done? For easy transportation. That is why this layer is also called as transport layer. You understood? Transport layer? Okay. So the transport layer is also responsible for picking a protocol, TCP or UDP. If you are telnetting, it will definitely pick only TCP. If you are doing some sort of voice communication, like I am talking to you, for voice communication, it is going to be UDP. Now, who decides this? Based on the application that we use, transport layer only decides it. Right now, I am talking to you over Google Meet. That is the application layer. That's the application. For that application, UDP is what transport layer is picking up. Let me show all the protocols. See, this jumping is going very fast, like 4,000 packets. As I am talking to you, you can see thousands of packets are sent from my laptop to your laptop. And this is using UDP. But I'm not using IPv4, I'm using IPv6. This is IPv6 address. If anyone says IPv6 has not yet come, it is yet to come, he or she is not aware of IPv6. IPv6 have already come. You see, this is my source IPv6 address. This is your network destination IPv6. Actually, this is not yours. This is Google. We are using Google Meet. So traffic goes via Google. It goes via Google Meet. And you see, it is using UDP, User Datagram Protocol. It's using User Datagram Protocol. All right. So TCP versus UDP. Both these protocols work in transport layer. TCP is connection oriented, demands acknowledgement. UDP is best effort delivery. What is best effort delivery? It will send, that's all. My job is over. I did my best effort delivery. Whereas TCP is not like that. After sending, it will wait for acknowledgement saying, I received your packet, give me next packet. Only then it will send the next packet. Say, for example, I'm sending you a packet. You received the packet. And I don't wait for you to send acknowledgement. I keep sending second, third, fourth packet, meaning I'm UDP. But after I send the first packet, if I wait for you to send an acknowledgement saying you received the first packet and you want the second packet, only after seeing the acknowledgement, if I will send the second packet, then I am TCP. Do you understand? TCP will not send any packet until an acknowledgement for the previous packet is received. UDP is not like that. It won't wait for any acknowledgement. It keeps sending without checking whether the destination is there to receive or not. Whereas TCP is connection oriented. It will definitely check the receiver. It will check with the receiver. If the receiver is there, the receiver should send the acknowledgement. If I get an acknowledgement, then receiver is there. This is what connection oriented. say for example, I call you, and means I call you through the phone is ringing. As soon as you pick, you say hello. I hear your hello. Then I start talking the original content. That is what connection oriented. Let's say I'm angry with someone. This is not good. Assume I'm angry with someone. And that someone picked the call. I don't wait for that someone to say hello. As soon as he picked the call, I just start telling everything that I want to tell, and then I hang the phone. What is that called as? Best effort delivery. I assume that the other side, the right person is there, and he listened to all my talking. It's an assumption. There is no guarantee. Who knows? When I call, he might have not taken the phone. Someone might have taken his phone because it is ringing. But I did not check whether the right person is there on the other side or not. I just keep sending. That's called best effort delivery. Now both are good only in what way? TCP is good wherever you need secure communication. Wherever you need secure communication, you need your TCP will be there. Telnet is a very important communication. I want it to be secure, so TCP will come. TCP will be used. But in our class right now, we are having online class, and you saw UDP is used, not TCP. Are we not focusing on security? See, we do need security, but more than that, what we need is fast communication. We don't want any voice getting break in the middle. If we use TCP, then there will be a voice break. You know why? Because when you receive a packet, then you have to stop receiving and send me acknowledgement. After seeing the acknowledgement only, I'll send the second packet. So there is a time interval in between, which is not good for voice. தொடர்ந்து நான் பேசுறது கேக்குதுன்னா அது காரணம் டிசிபி பயன்படுத்தாம யூடிபியை பயன்படுத்தினதுனாலதான். டிசிபியை பயன்படுத்தி இருந்தா என்னுடைய ஒவ்வொரு பேக்கெட்டுக்கு நடுவுலையும் அக்னாலஜ்மெண்ட்டுக்காக வெயிட் பண்ணி டைம் ஆயிருக்கும். அப்போ உங்களுக்கு அந்த தொடர்ச்சியா அந்த வாய்ஸ் வந்து சேராது. நான் சொல்றது புரியுதா? The fast communication, the instant messenger, the WhatsApp, Facebook Messenger, இதெல்லாம் என்னதான் யூஸ் பண்ணுது? யூடிபி தான் யூஸ் பண்ணுது. Fast communication. Right? Example for TCP is what we already know on Telnet. You also know HTTP. The secure HTTP is also called as TLS. Earlier it was called as HTTP. Yes. Now this all will use TCP. Okay. UDP is voice, like real-time protocol. Voice. Right? There are many UDP protocols actually. There is a protocol which we are going to learn called RIP, Routing Information Protocol. Routing Information Protocol, which also uses UDP. UDP 520 is the port number. Don't worry about the port number now. It is 520, but no need to know now. We will be learning that later. So this is the difference between TCP and UDP. And this TCP and UDP works in which layer? Yeah, transport layer. Now all these layers that we have seen so far, layer 5 to layer 7, sorry, layer 4 to layer 7, we have seen layer 4 to 7. These these four layers, 4, 5, 6, and 7, these four layers are taken care by your operating system. See, you don't need to do anything with this four layer. You have an operating system in your computer, right? That only will do all this job. We don't have much work to do in this layer. If you're running Linux will do this job. If you're running Windows will do this job. If you're running Ubuntu will do this four layer job. Where do we work? As a networking team, we work on layer 3 called network layer. This is layer 3. In network layer, we have a name for our data called packets. We work in network layer. Our router works in network layer. You remember I told you yesterday, routers are to connect between two different networks. So router works in which layer? Layer 3. What does this layer 3 do? Layer 3 provides source IP address and destination IP address. In our example, which one is the source IP? 10.0.0.1. Which one is the destination IP? 10.0.0.2. And what protocol works in this layer? IP, IPv6, and much more. We will be learning more protocols like EIGRP, OSPF. They also work in this layer. Let us not focus on those protocols. Now, as of now, in layer 3 network layer, what protocol works? IP, IPv6. Only this much as of now you need to know. What is our data called as in network layer? Packets. After this, what happens in data link layer? Data link layer, a source MAC address and destination MAC address is added. You remember in bridge and switch we saw MAC address. That is why bridge and switch are called as layer 2 device. You remember yesterday we saw about bridge and switch. They use what? MAC address. They learn MAC address. They forward packet based on MAC address, not the IP address. That's why switches and bridges are called as layer 2 device. What is an example for layer 3 device? What is an example for layer 3 device? Priya? Hmm? Yeah. Yeah. For network layer, what is the device name? No, the device. The device work in this layer is what? Router, right? Router works in layer 3. What is the device worked in layer 2? Very good. Bridges and switches. And when the packet is added with the source and destination MAC address, in our example, AAA, BBB, isn't it? When this MAC address is added, our data will be called as frames. Frame, okay? Frame. And this is the layer where the protocols like Ethernet, PPP, point-to-point protocol, HDLC. If it is wireless, then it is IEEE 802.1a, B, G, N. All these protocols work in data link layer. We'll talk about these protocols later. But what you need to know is in data link layer, we call our data as frames, and the device works in this layer or bridges and switches. At last, our frame is converted into binary bits and sent in the wire. We call it as physical layer. Physical layer is what layer? Layer 1. All right, so data goes in the form of bits and bytes. All right. Okay, so we have seen the 7 layer of preparing our data so that it can be sent over the wire in bits and bytes. What we are going to see in the next class is this bits and bytes reaches B. Then what happens? We saw only the sending side so far, isn't it? We saw A sending. Now on receiving this, what B will do is what we will see in our next class. Do you